Okay, last part of 3.2 is going to deal with word problems, application problems. Now, the two examples we're going to look at are just kind of cute word problems, but this is the process that you would use no matter the situation. And usually what works out is for every unknown you have, for every variable you need to find, you're going to need that many equations. So what we're going to do is work through the process. Now, this is not the only way to solve this, but it's the process I use when I'm solving these problems. Okay, so the first one we're going to look at. When the Alaskan Frozen Toads sell out the stadium for their outdoor water polo matches, they make $740,000. Lower level seats cost $28, upper level seats cost $16. There are 5,000 more upper level seats than lower level seats. How many of each seat is there? So I'm going to start by just writing down everything we know or everything we need to know or what we're trying to find. Okay? I know we're trying to find how many lower level seats, and number of upper level seats. Again, I used X and Y because that's what we have been using. You're more than welcome. Some people like keeping it as L and U for lower and upper, but these are what we're going to be trying to find. We have two unknowns that we want to know about. Now, what we know about those unknowns, for the lower level seats, we have $28 a seat. For the upper level, we have $16. We also have the total amount they're going to make for that if they sell out the stadium. We have $740,000 if every seat gets sold out. Okay? Now, this line here, there are 5,000 more upper level seats than lower level seats. So if I have more upper level seats, not up high, my answer is because there's more seats up there, okay? We have more upper level seats than lower level. We need to add 5,000 to this lower level to make them equal. And if they're equal, then we can write an equation for it. So if we add 5,000 to our lower level, then we can have an equation. Y, our upper level seats, equals X plus 5,000. So that gives us one equation to work with. Another equation is on to deal with this money here. Now, most times, not every time, but most times, if they give you a total, I find it's on to be on one side of the equal sign by itself. So I'm going to put that 740,000 all by itself over there on the right-hand side. The $28 and the $16, that's on to go with the number of seats. Okay, for every seat, they're making $28 for lower level, $16 for upper level, and it's on to equal that 740,000. Our variables for the number of seats are X and Y, so I'm going to put them with the corresponding price for those seats. 28X plus 16Y. And now we have our two equations. And this is where now you have to remember how we solved systems, and we have one variable by itself, so I'm going to use substitution. We have that Y all by itself here, so I'm going to take that Y, X plus 5,000, and plug it in. Got a 0 there. Okay, now this is the equation we should be able to solve. We should be able to do the distributive property and then solve for X. Okay, combine like terms, subtract my 80,000. Okay, so I get 44x equals 660,000. Divide by x, that should give you 15,000. Okay, I have the answer here. Let me just double check my math there. Yep, should be 15,000x. And now just like before, we need to get the y. So if we have 15,000x here, 15,000 equals x, we can just take that x, plug it back in, just like before. Pick which one looks easier. I'm going to do the y equals x plus 5,000. and we have y equals 20,000. So now the last thing is just label those. This is a word problem. Those values have meaning. The x and y have a little more meaning to it, so we should write it out. Our x is lower level seats, so that means 15,000 lower level seats and 20,000 upper level seats. Okay? Again, I don't need a big paragraph or a novel explaining what the numbers mean. Just quick, the number 15,000 and label what they are. Lower level seats, upper level seats. Okay? And that would be the final answer I'm looking for here. So writing out all the information is important. This is how you're organizing yourself. You know what the variables are that you're looking for, so you have to define those variables, and you're writing out all the information we know, how much the seats are, what our total is, and then that's how we're going to get our equations. And the solving part is what we should have known from earlier. Okay? The junior class at Baconville High School sponsors the prom. This year's junior class did not earn enough money to offset the cost, so the junior class members have agreed to pay a higher ticket price than the seniors. The juniors' tickets will cost $10.50, and the seniors' tickets will cost $7.50. A total of 570 students went to prom. They made a total of $4,905. How many seniors and juniors went to prom? So I'm going to start off the same way, writing out what my variables are, what I need to find, and the information they give us. So my x, I'm going to have that as the senior price, or we want to know how many seniors. So x is going to be the number of seniors, and y is the number of juniors. We know that the seniors paid $7.50. Juniors paid, $10.50. And the total amount they made was $4,905. Now, they gave us the second total. Total amount of money was $4,905. Total number of students was 570. Okay, so they gave us two totals this time. Okay, and again, when they give you a total, I'm thinking that's going to be on one side of the equal sign all by itself. So I'm going to set up my two equations with these two totals by themselves. So I have equals the $4,905 and equals the 570. Now one rule is units are going to stay together. Okay, so if we're dealing with $4,905, that money is going to stay with the money. So that means the senior ticket price, the junior ticket price is going to stay in that equation. So I'm going to do 750x plus 1050y. That's just figure out how much money they're making. Every senior paid $7.50. Every junior paid $10.50. Now, we don't have any more information, but we do know X is the number of seniors, Y is the number of juniors. If you put those variables together, that gives us our total number of students. So no values in here except for the variables. X plus Y equals 570. Now this one again, you need to think about how you can solve this one. We have x plus y equals 570. So you could get one of those variables by itself and use substitution. You also, variables line up nicely here. The x's are lined up, the y's are lined up. So you could also use linear combination. That's going to be up to you which you want to multiply through. Okay? So if you multiply through by 1050, that's going to make the y's cancel out. So I'm going to multiply that bottom equation by 1050. I'm just going to rewrite 750x plus 1050y equals 4905. Okay, if I multiply through that second one, you're going to have 1050x plus 1050 50y equals, and I have it here as 5,985. Now, just like before, we're going to subtract these. Okay? Our y's, 1050 and 1050, are the same coefficients. So if we subtract these, they will cancel out. They cancel out. Negative 3x equals, that'll give us negative, I have 1,080. Oh, forgot a 0 there. Negative 1,080. And if you divide through that now, divide by negative 3. Okay, two negatives make a positive. Our x should equal 360. Okay, so our x is 360, and now you have 360 here. You should be able to see which equations on be a little easier. We have the money at 750, 1050, having to deal with decimals. Second equation is just x plus y equals 570. Plug that 360 into x, and you should be able to do subtraction and get your y. 360 plus y equals 570. Y equals 210. So just like before now, make sure you label your final answers. Our x is the number of seniors, so that means 360 seniors went to prom. 210 juniors went to prom. And there's my final answer. So one-word labels are fine. Again, I don't need paragraphs, I don't need a novel, just something to show me what those numbers actually represent. Okay? So there's two examples, one with substitution, one with linear combination. I feel like the important thing is writing out the information and getting the equations. Once you get the equation, it's going to be up to you to decide how you're going to solve that system of equations.